Good morning students. So in this class we are going to discuss about law of conservation of linear momentum. So the conservation laws, there are three, that is conservation of energy, conservation of linear momentum, then conservation of angular momentum. So by combining Newton's second law and third law, so we can derive the conservation of linear momentum. So consider two particles, particle 1 and 2 interact with each other. So there is a force acts. So particle 1 exerts a force F21 on particle 2. So at the same time particle 2 exerts equal and opposite force on particle 1. So particle 1 exerts, so particle 1 and 2 interact with each other. So particle 1 exerts a force on particle 2, that is F21. At the same time particle 2 exerts equal and opposite force on particle 1. So you can write it using Newton's third law, that is action equal to minus reaction. So F21, so the particle 1 exerts on 2 equal to minus F12. So this is in positive direction, this is in negative direction. So minus F12 should be, so that is minus F12. Then in terms of momentum, that is Newton's second law. So F12 equal to dP1 by dt, F21 equal to dP2 by dt, that is differentiation of momentum. So P1 is a momentum of a particle 1 which changes due to the force F12 exerted by particle 2. So P1 is a momentum of a particle 1 which changes the force F12, that is F12 from 2 to 1 exerted by particle 2. So in similar way that P2 is a momentum of particle 2 which changes due to the force F21 exerted by particle 1. So by combining equation 2 and 1, so here F12, F21, here F21 equal to minus F12, just substitute. So we will get dP1 by dt equal to minus dP2 by dt. So that minus, it goes to left hand side. So dP1 by dt plus dP2 by dt equal to 0. So taking common that differentiation with respect to time. So d by dt of P1 plus P2 equal to 0. If you differentiate a constant, then only we will get a 0. So P1 plus P2 is a constant vector because momentum is a vector. So total momentum of a system is equal to P1 plus P2. So we can define like this. So if there is no external force acting on the system, so here the system is that particle 1 and 2. So there are no external force acting on the system, then the total linear momentum of a system, that is particle 1 and 2, that is P total, is always a constant vector. So that is conserved. So the total momentum is conserved. That is conserved means conserved in time, that is the momentum P1 and P2 can vary in such a way. Then so the total momentum is always constant vector. That means here the force F12, F21, that is particle 1 exerts on 2, at the same time particle 2 exerts on 1, that is F21 and F12. These two forces are internal forces, so they are constant because it is there is no external force acts from the outside. So the conserved, that is the total momentum, that is total linear momentum, that is constant vector, is conserved. So in this class we have discussed, that is law of conservation of linear momentum. So this is the law if there are no external force acting on the system. So particle 1 and 2 constitute a system. So particle 1 and 2 interact with each other, it exerts force on each other. So there is no force external, there is external force acts on the system. So the total linear momentum of a system of particles is conserved, that is constant vector. So okay, so